In this question, you're given that matrix A is 0 minus tan alpha by 2, tan alpha by 2, 0. And I is an identity matrix of order 2 by 2. Show that I plus A is equal to I minus A times the matrix cos alpha minus sin alpha and cos alpha. So again a very straightforward question. We'll find the LHS, we'll find the RHS, we'll see whether both are same or not. So I plus A is 1 0 0 1 plus 0 minus tan alpha by 2 tan alpha by 2 0. That is equal to 1 plus 0 is 1, 0 minus tan alpha by 2 is minus tan alpha by 2, tan alpha by 2 1. So this is I plus A. So what is, this is my LHS. What is my RHS? I minus A times this. So first let me write I minus A 1 0 0 1 minus 0 minus tan alpha by 2 tan alpha by 2 0. So this is equal to 1 tan alpha by 2 minus tan alpha by 2 and 1. 1 minus 0, this and this. So this is I minus A times this. So let us write my RHS completely. So I minus A times cos alpha minus sin alpha cos alpha is equal to, so I minus A is 1 tan alpha by 2 minus tan alpha by 2 1 times cos alpha minus sin alpha and cos alpha. You know how to multiply matrices. First row times first column. 1 into cos alpha is cos alpha tan alpha by 2 into sin alpha. Cos alpha plus tan alpha by 2 into sin alpha. So tan alpha by 2 is sin alpha by 2 by cos alpha by 2 into sin alpha is 2 sin alpha by 2 cos alpha by 2. So we'll simplify it afterwards. And this is the first element. What is the second element? First row into the second column. So 1 into minus sin alpha is minus sin alpha plus tan alpha by 2 times cos alpha. And next row times first column. So minus tan alpha by 2 times cos alpha plus sin alpha. And second row times second column. So minus tan alpha by 2 into minus sin alpha. That is tan alpha by 2 into sin alpha plus cos alpha. So we need to prove that this is exactly equal to this. So let me try to simplify each of these terms. So cos alpha can be written as 1 minus 2 sin square alpha by 2. This minus 2 sin square alpha by 2 and plus 2 sin square alpha by 2 gets cancelled. So you get 1 as the answer. Good. And this is exactly same as this if you see. Cos alpha plus tan alpha by 2 into sin alpha. So if you do the same substitution, you do the same working, this will also turn out to be 1. And these two, I need to prove this as tan alpha by 2. If I prove this as tan alpha by 2, this will automatically become minus tan alpha by 2. Because sin alpha has become minus sin alpha. Minus of this has become plus of this. So these two are negative of each other. Now, if I can prove this as tan alpha by 2, my work is done. So how can I prove this as tan alpha by 2? So let us try to convert things into alpha by 2's. So let me just try to simplify this. So minus tan alpha by 2 times cos alpha is 1 minus 2 sin square alpha by 2 plus sin alpha is 2 sin alpha by 2 cos alpha by 2. So that is equal to minus tan alpha by 2 into minus tan alpha by 2 into minus 1. So instead of 1 minus 2 sin square alpha by 2, I write it as 2 cos square alpha by 2 minus 1 is also same. Cos alpha can be either written as 1 minus 2 sin square alpha by 2 or 2 cos square alpha by 2 minus 1. So if I write this, so minus sin alpha by 2 by cos alpha by 2 into 2 cos square alpha by 2, minus into minus is plus tan alpha by 2 plus 2 sin alpha by 2 cos alpha by 2. So cos alpha by 2 gets cancelled. So minus 2 sin alpha by 2 cos alpha by 2 plus 2 sin alpha by 2 cos alpha by 2 gets cancelled. So that is equal to tan alpha by 2. So this has been turned out as tan alpha by 2. Hence this is the negative of this. So this will be minus tan alpha by 2, which will be exactly same as the LHS. Hence LHS is equal to RHS. Hence proved. Thank you.